Here we're going to go over the endocrine responses to stress. First of all, we should define what we mean by stress. Stress is anything that's life-threatening, like an infection, trauma, blood loss, hypoxia, or anything that can evoke a strong psychological response, a negative psychological response. So it can be an angry lecturer, or it could be a large bear, or it could actually be the result of surgery or feelings about surgery. And the stress response resembles exercise in that it prepares you for a fight or flight response. There's a large sympathetic outflow, but it's not always seen in conjunction with an expenditure of energy. Your job might be stressful and you might suffer chronic stress through just your mental feelings. But regardless of the source of stress, your body responds through releasing hormones that facilitate the release of energy and the storage of energy. And so whatever the stress response is, generally you get the release of ACTH from the hypothalamus, from the pituitary gland, and this will stimulate the release of cortisol from your adrenal glands. And cortisol will then start to increase your blood glucose levels by producing new glucose through gluconeogenesis. It would also cause proteolysis to have a source of substrate to turn into new glucose. And then you also have a sympathetic stimulation, which leads to the release of epinephrine and glucagon and to the inhibition of insulin. And then you can have your blood sugar raised through glycogenolysis. But also cortisol, epinephrine and glucagon will also start stimulating lipolysis, and you'll have an increase in free fatty acids. The overall response then is to mobilize energy substrates so that you're prepared to combat whatever stressful event is perturbing you at the time. This shows you all the sort of feed forward and feedback mechanisms during stress. So whatever the stressor is, whether it's a local injury or something perceived, you have stress signals that would signal into the cortex and limbic system, producing a release of norepinephrine on neurons, and this will enhance your behavioral arousal and your aggressiveness. And also the stress signals will then cause a release of CRH from the hypothalamus onto the pituitary to release ACTH to release cortisol into the blood. Also, you'll have a sympathetic outflow which will release epinephrine from the adrenal gland, and as a result you have energy mobilization and redistribution of your cardiovascular response. The release of epinephrine shuts down your visceral function or suppresses your visceral function, and cortisol inhibits your immune response. It also inhibits your growth and reproductive functions, and your feeding and your desire for sexual activity will go away. And then cortisol has a number of negative feedback mechanisms on CRH release, on norepinephrine as well. And this then points to the whole control mechanism of the stress response. Catecholamines are released through either the adrenal gland or sympathetic outflow. And in this diagram you have hypovolemia, hypoglycemia and hypothermia, and how the different catecholamines respond to these stresses and what they do physiologically in hypovolemia. So if you've lost a lot of blood, you'll have vasoconstriction, you'll increase your heart rate to try and maintain cardiac output. And then you have in hypoglycemia, you get lipolysis to produce a second energy source, glycogenolysis to raise your blood sugar. Glucagon secretion will then help raise your blood sugar as well. And then you have gluconeogenesis and the inhibition of insulin secretion to maintain your blood glucose levels. Then with hypothermia, you have vasoconstriction, so that makes blood flow into the core rather than in the periphery. You have heat production as the increase in energy then stimulates muscular activity and an increased metabolic rate to raise your core temperature. Cortisol inhibits the immune response during a stressed episode. So this is important if you're cut. You don't want your immune response to have an exacerbated response while you're actively dealing with the stressor. And cortisol inhibits the immune system at many points. And it's shown in this figure where the different points of inhibition are. So you have inhibition of the release of interleukin-1, which is a very important inflammatory cytokine. It lowers your fever. It will suppress T cell responses by preventing the release of different cytokines like interleukin-2 and TNF alpha. It will inhibit the production of prostaglandins through inhibition of cyclooxygenase. It would also inhibit neutrophil function through inhibiting leukotrienes, and it will generally inhibit the production of arachidonic acid, platelet activating factor, and nitric oxide. So it inhibits a large part of the immune response, and this is vital during a stress episode. So this reinforces the role of cortisol in inhibition of the immune response. So there's a stimulus to the immune response, you get cytokine release. This stimulates CRH release and increased ACTH release, and then cortisol feeds back and inhibits this immune response to prevent it from becoming dangerous. This graph shows how your blood glucose levels change with the stressor. In this case, the stressor is hypoxia, and the longer you're in hypoxia, the higher your blood glucose levels get, and this is concurrent with the release of glucagon. So the glucagon is released by sympathetic stimulation due to a stressor, and therefore your blood glucose levels rise. Here we see the different effects of the different hormones during the stress response. Epinephrine, as we talked about previously, increases and it reinforces the sympathetic nervous system for fight and flight, mobilizes carbohydrate and fat stores, and this increases blood glucose and blood fatty acids. Cortisol is released, and this mobilizes energy stores and metabolic building blocks for use as needed. It turns proteins into amino acids, and amino acids into sugar, and it produces blood fatty acids also. It also reinforces epinephrine. It's permissive for epinephrine release, and glucagon is increased during the stress response, and this helps epinephrine. And then the other hormones that are not so metabolic but are also released from structures we've talked about. Aldosterone is released from the adrenal cortex, but this is mainly involved in fluid retention. It conserves salt and therefore conserves water, and this helps sustain blood pressure and volume in in the advent of hypovolemia. Vasopressin released from the posterior pituitary increases plasma volume and causes arterioles to constrict, also maintaining your blood pressure. And so I've talked about cortisol being permissive for epinephrine release, and that's because it stimulates the production of the last step of epinephrine formation, and this is phenylenmethyltransferase that stimulates the formation of epinephrine from norepinephrine. So if you have higher cortisol levels in your body, you'll have higher epinephrine levels in your adrenal gland, ready for release and ready for a strong metabolic and sympathetic response.